In today's video, we're going to discuss points and slope. So points and slope are two different concepts that discuss the makeup of lines when we're graphing in two-dimensional space. So everything that we're going to do in this lecture and the next is going to be built along the XY axes. Our x-axis goes horizontally, our y-axis goes vertically. The very middle we refer to as the origin. As we go to the right in the x, we're going in the positive direction. So I'm going to refer to this now as the positive x. As I go to the left, I'm going in the negative direction. Similarly, as I go up in the y direction, this is a positive value. As I go down in the y direction, this is a negative value. An XY graph like this can be broken up into individual points by making marks along the axes. And labeling the intersection of these points with a unique address. So here I've put a point out in space. So let's move it over. Put a point out in space over here, and I want to know, what do I call this thing? I count to the right, 1, 2, 3, 4. I can count up, 1, 2, 3. And this point happens to be when the x value is 4 and the y value is 3. So an address of a point is always written with the x value first and the y value second. This address, or this ordered pair, has a unique location in the graph. In other words, there's only one place where 4, 3 exists. The homework problem similar to this, I found in number 4, gives you a list of points out here and asks you to find the address of each of those. So I'm just going to zoom in on this graph here. I need to zoom in more, sorry. That's better. And I want to find this location of A. And so what I do is I start the origin with my finger or cursor, and I ask myself, how far do I have to go in the x? I go over here to 2 in the x, and then I find out how far do I have to go in the y value, and I'm also going a positive 2 in the y value. The intersection of those is 2, 2. And so my ordered pair, don't forget to put parentheses for your ordered pair, and a comma in between the values. Point B, notice, is back here to the left. And so what happens for point B, again, we read our x value first and our y value second. But notice that for B, we're going back to the left. The x value where B lines up happens to also be the same x value where this F point lines up as well, is -6 in the x. So I know that my B value here has an x value of -6. Then I go up to find out what it is in the y value, and it looks like it has the same y value as A. Both of these happen to have a y value of 2. And so the ordered pair for B would be -6, 2. Here we have another one, C. Again, I start in the origin. I go left or right first. In this case, I have to go right, so I'm going to have a positive x value. It turns out that the C point lines up at +2 in the x. But notice that C value is way down here, and because I'm going down below this line, I'm going to have a negative value in the y. Turns out when I come over here to find out along the y-axis that it has a height, or a y value, of -4. Looks like D has a negative x value and a negative y value. It has a -3 in the x and a negative 3 in the y. E is a very interesting one because E and F as well fall exactly on the axes themselves, which means one of the values, either x or y, is going to be 0. So remember to always start at the origin when you want to find these values. It's easy to get the 0 misplaced when you're graphing these kinds of points. But notice in this one, as I start at the origin, I'm not going left or right any in order to get to E. Because I'm not going left or right any, and x is a left or right motion, it's going to be the x value that's 0 in this case. It's the y value that tells me the height. So I'm not going to go left or right any, but then I'm going to go up 3 units. And so this point would be 0, 3. Lastly, for the f value, I start at the origin and immediately I have to go left 6 units. And so it's the x value that's negative 6. But when I get here, I don't go up or down at all, which tells me that the height, or the y value, is 0. So at this point, it's negative 6, 0. So that's all about points. Now we can start talking about the idea of lines. So what is a line? A line is a collection. There we go. A line is a collection of points. All of those points are generated by some mathematical equation that we can use as an input and an output to generate these. In the problem that I have right here, I'm looking at a linear equation, or the line, y equals 3x minus 1. For these problems, I have two variables. I have an x that's unknown, and I have a y that's unknown. These two values work in motion together. One of them, the x value, we refer to as the independent variable. That means we're allowed to choose whatever values we like for this number. What we get when we plug in certain numbers and apply the mathematics on the right-hand side to them is what gives us the dependent variable, or the y value. And again, these two values work in unison. I plug in a certain value for x into the machine. In this problem, I'm going to multiply it by 3 first. Then I'm going to take that answer, I'm going to subtract 1, and that's going to give me the output. The collection of those two, input and output, is what we use to graph the address of the point in space. So in this problem, we're going to make a table first. In the table, the x value are points that we want to choose. In this one, the homework problem chose for us the value negative 2. In truth, we could choose whatever values we want if we want to graph this line. So for this one, though, we're going to start with x equals negative 2. And on the side, I'm going to calculate when x equals negative 2, what's the y value? I get y equals 3 times negative 2 minus 1. That is y equals negative 6 minus 1. Y is equal to negative 7. So in other words, when x is negative 2, the y value is negative 7. This is an ordered pair, somewhere out in space. Negative 2, negative 7. What I'm going to do is I'm going to make myself a little graph down here to identify where that's at. Negative 2 in the x and negative 7 in the y. It's going to be somewhere down here. Well, there we go. there's my first point. Then I go back up here, plug in my y value, and it gives me another one for negative 1. When I plug negative 1 in for y, I get y is equal to 3 times negative 1 minus 1. That is negative 3 minus 1, or negative 4. So when x is negative 1, the y value is negative 4. Going back to my line, negative 1 is here. Going down to negative 4, 1, 2, 3, 4, would give me a point right here. Now in order to graph the line, I only need 2 points. So I can connect these two maybe with a ruler or something, and I can continue going. For this particular problem, we're going to plug in a few more points, and we're going to make sure that they all fall on the line. If, as we're graphing here, one of these points ends up, I don't know, way out here or something, then we know that something is wrong because our points are no longer going to make a line. So what this does, it helps us verify that the math that we're doing is going to work out. The next one asks us to plug in 0. 0 is a special value we're going to talk about in the next video even more. It's referred to as the y-intercept. It tells us where the line is going to cross this vertical line right here. Plugging in y into this equation, 3x minus 1, would give us y equals 3 times 0 minus 1, which is 0 minus 1, or just negative 1. So our third point that we're going to graph here is 0, negative 1. So I'm not going to go left or right any, and then I'm just going to go straight down to the negative 1 value. And you can see that I did an okay job, but not a great job making these all fall on the same line. How many of these do you want me to do? You may also see a pattern as you're doing these. So notice that as we increase the x value by 1, we're increasing the y value by 3. Negative 7, add 3 to that. Negative 4, add 3 to that. Negative 1, add 3 to that. We should be getting positive 2. And so we can see some pattern emerging. But even if you don't see the pattern, it's okay. We could plug in y equals 1 in this case. We get 3 times 1 minus 1, which is 3 minus 1, or just 2. So when x equals 1, our y value is 2. That gives us the ordered pair 1 in the x and 2 in the y, which can be plotted right here. Again, kind of following our line. I didn't do the best job here. Just make your points real big. And we can connect these points together like this to make our line. Again, adding 3 to this for the sake of time, I can continue to add 3. And then it asks us to choose which one of these is the graph. Notice something about our graph right away, that it increases as we go from left to right. So we should be seeing something like B or D as the right choice. The other thing that we can notice about it, these are really hard to see, I have to zoom in to get to look at the differences. But another thing that we want to look at is where that y-intercept is. Where do you cross the y? Do you cross it above the x line? Up here? No. In this case, you cross below the x-axis down here. So that's another characteristic we're going to look for when we choose the right graph. If we look real closely to this one, it actually does not cross below the line. It crosses the y-axis above the line. However, this one right here, and again, you might want to zoom these in even more for yourself. Well, don't do a horrible job like I just did. There we go. And you can see that this one's a little bit better, that it actually crosses just below the x line, just like our graph does. And so we want to choose this one as well. Construction of lines leads us to the discussion of slope. So what is slope? Slope is the rate of change in a line. It tells us how quickly or slowly a line is changing. It also tells us by its positive and negative sign whether a line is increasing as we read from left to right or decreasing as we read from left to right. In the case of a positive slope, the graph is increasing as we read from left to right. In the case of a negative slope, the graph is decreasing as we read from left to right. We use the letter m to define slope, and it can also be thought of as the rise over the run, or more explicitly, the change in y over the change in x. So what we want to do when we're graphing or looking at slope, we want to determine what it is we want to find out as we go from one point to the next, how do we change in the y value? And as we go from one point to the next, how do we change in the x value? For consistency, I prefer to read 2 points, the leftmost point first and the rightmost point second. What this does is it always makes our x value positive. Now the y value can be positive as well, such as the case in here as the graph increases from left to right. But if the graph were heading the other direction, then as we would read it, it would be going down. So our first point is always going to, our first, I shouldn't say point, but the first idea that we want to keep in mind about graphing these or finding the slope is that we want to choose the points from left to right. So in this one, let's calculate its slope. We have a point down here. I'm going to zoom in a little bit so I get a better idea of what this point is. In the x direction, this point looks like it is -2. And in the y direction, this point is -4. Remember, it's down here, so it's not +4, but it's -4. This is that first point. The second point that we found is 4 in the x. And the y value is 4 in the y. So in other words, we want to know what's the slope as we go from -2, -4 to 4, 4. So for this particular problem, we have a picture. So it's actually easier with a picture than it is when we just have the points. So I'm going to show you 2 different ways of doing this problem. The first way is just by simply looking at the picture and counting the number of steps that we make to go up. That's our y value change. And then how many steps do we need to take in order to go over to get to this point. So that's what I'm going to do first. Let's count this out. We're going to start here, and we're going to work our way all the way up until we're even with this point over here. So I count it out, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So my change in y in this problem is going to be 8. That goes on the top. And now I'm going to count over the x values to find out what my change in x is. Don't count the point that you're already on. So from here, we're going to go 1, 2, 3, 4, 5, 6. So as I go from one point to the next in this line, I go up 8, a +8, and I go right 6, a +6. Notice that they ask you to type an integer or a fraction, which is what we have here, but always simplify your answer. So this fraction, 8/6, can be simplified. So we're going to write this slope as 4/3. Our slope is 4/3. Here's another one. For the next one, the only difference in this one is that as we count the points over, the y value, when we find that, notice that we're heading down. So again, we want to always choose points from left to right. So we're going to start at this point and we're going to end at this point over here. We're going to count down our spaces. So again, our m value is change in y over change in x. So in this case, because I'm going down y values, 1, 2, 3, 4, I'm going to use a negative attached to that y value. Again, because I'm going downward this time. The reason why we choose our points from left to right is that the x that we count over is always going to be positive. In other words, if I start here and I go this direction, I'm going positive in the x. So I don't have to worry about a double negative making a positive or anything like that. Just noticing the fact that this line is going down as we read from left to right should tell us that our answer is negative. So again, we went down 4 units, and now we have to go to the right 1, 2, 3, 4, 5 units. So the change in x is a positive 5. So this tells us that our slope is negative 4 over 5. So how do we work on these problems if they don't give us this nice points? Well, a couple different ways. One of them, we could just simply graph the points ourselves. This is what problem 14 asks us to do. It gives us 2 points, negative 1, negative 3, and 3, negative 3, and we need to graph them. So I'm going to go over here and I'm going to click on this and it's going to open it up for me. The 2 points I want are negative 1, negative 3, and 3, negative 3. So I go over here and I click on this line tool to graph lines. And the first point I want to graph is negative 1 in the x and negative 3 in the y. So I'm going to go to the left 1, and notice at the very top up here that it's going to show you what your point is as you're moving along on the graph. So this is a really good helpful tool to make sure that you're graphing the point properly. We start at 0, 0 again. I go to the left 1, that's negative 1, and then I'm going to go down 3. 1, 2, 3, and I'm going to click and make a point there. Then I go back to the origin, 0, 0, and I'm going to make another point, 3 in the x, so I go to the right 3, and negative 3 in the y. 1, 2, 3, and I graph another point right there. Those are my 2 points. Notice I hit save, it shows it up here, and then I can check to make sure I graphed it properly. For this one, they want to know the slope of the line. And this one's kind of interesting. Let's talk about this. What is the slope of a line that's horizontal? Notice that this value has no rise to it. It doesn't go up or down at all. And remember that our m value is the change in y over the change in x. As I go from this point to this point, again, this first one was an x value of negative 1, and the second one was a y value of, and an x value of positive 3. Both of these happened at negative 3. So m is change in y over change in x. We can see right away that the y value doesn't change at all here. There's no height change. And so it would be 0 on the top. And the change in x actually doesn't matter what number is down here because 0 divided by anything is going to be, as long as this isn't 0, it's going to be 0. So here we go from negative 1 to 3, which is a distance of 4. 1, 2, 3, 4. And so we get 0 over 4 as our slope, or just 0. So anytime we have a straight line, a horizontal line that has no rise, then we know that the m is equal to 0. So what happens if the line is going the other direction? What if we have a line that's vertical? So this has all rise and it has no run. There's no change in x in this problem. I'll just choose 2 points on this graph. Maybe one right here and one right here. And we can see that if I go from this point to this point, I have a change in y. I'm going to say it's 4 minus 1. But the change in x, it's not changing in x at all. It's 0 on the bottom. And this leads us to big problems. As we learned earlier in the semester, we can't divide by 0 at all. So when we write out change in y over change in x, and we have a 0 on the bottom, we call those lines undefined. So vertical lines have no run, and so their slope is undefined. The last concept we'll talk about in point and slope is how to calculate the slope of a line if we don't have a picture. That was what we wanted to talk about in terms of the 2 ways of graphing slope or calculating slope. In the very first problem we did, I mentioned I would go over it in 2 different ways, and so I'd like to do that now. The very first slope problem that we did, I know this is graphing points. Very first slope problem that we did was this value right here, and we have these 2 points right here. But what if instead of giving us those 2 points in a graph, they would have given us the ordered pairs? Remember, the ordered pairs for that problem were negative 2, 4, and 4, 4. Oh, sorry, negative 2, negative 4, and 4, 4. We want to calculate its slope. So remember that we mentioned the slope can be thought of as the change in y on the top over the change in x on the bottom. Now we're going to write this out in a different way. I'm going to call this point 1. I'm going to call this one point 2. It doesn't matter which order you call point 1 and 2, but what's important is how you label them after that. So this is the x value of point 1. I'm going to refer to that as x sub 1, or just x with a little 1 on the side. This is what tells us that it's the x value of the first point. This is the y value of the first point, so we're going to call that y1. Over here, we'll call this x2 and y2. To calculate slope, if we just have these points in this way, we want to take the subtraction of the y values on the top, because remember, it's change in y on the top. I'm going to write that as y2 minus y1. And on the bottom, we want to calculate the change in x. Remember that I mentioned it doesn't matter what order we call these points 1 and 2. What does matter is that we stay consistent with labeling x and y. Notice that I have the second y value here. That means I need to have the second x value here. So we're going to subtract. This would be 4 minus negative 4 over x2 is 4 minus x1 is negative 2. Minus a negative makes a positive, and so we can get 4 plus 4 on the top, 4 plus 2 on the bottom. And here's where we got our 8 over 6 that we got last time. Remember, we simplified that into 4/3. So this is how we calculate slope. In the next video, we're going to look more at the equation of a line, that input-output discussion that we talked about, and we're going to use that in order to calculate important things about the line, like its slope, or its rate of change, and its y-intercept, where it crosses the y-axis.